All right, this time we're working on simplifying radicals. So the first step you want to do in simplifying radicals is to look at your factors of the number that's underneath the radical. So this is called a radicand. So I'm going to look at the factors of my radicand. So 12. So I have 1 and 12, 2 and 6, 3 and 4. Then I want to come over here and I want to see if I have any of my perfect squares in this list. I want to find my largest perfect square, and that would be 4. So I'm going to use this pair underneath. And one of the properties says that we can put them in like this and then split them up into their own individual. So we have a property that allows us to do this. So now I'm just going to find what my square root is of 4 and then 3. So I'm going to do them individually. So the square root of 4 is 2. The square root of 3, it's not a perfect square, so it's going to stay like that. We don't want a decimal in this case. We want our answer to look simplified like this. Again, perfect square, so that's how I got 2. No perfect square, that's why I left it as a 3. All right, let's come over and do 128. So my factors are 1 and 128, 2 and 64, 3 doesn't work, 4 and 36. So I want to find my largest perfect square in all of these numbers. So as I'm going down my list, I have 4, that's here, 36 is here, and 64 is here. So this is my largest. So when I break it up, I'm going to use 64. So let's do that right now. So I have 64 times 2, and now I'm going to use my property and break them up individually into their own individual pieces. And then I'm going to find my perfect square, which was 8, and this cannot be reduced any further. There's no perfect square for 2, so this is my simplified answer. All right, let's take a look at another one. And I'm going to do the same thing that I did before. I'm going to break it up. So my 2 is going to stay on the outside, and then I'm going to do 18. So 1 and 18, 2 and 9, 3 and 6, and 4 doesn't work, 5 doesn't work, and we would just be going back because 6 is already here. So let's look at our list. So 9, that is our perfect square. So we're going to use this piece right here underneath. Now I'm going to break it up. And now I'm going to simplify. This becomes 3. This cannot be changed unless you do a decimal, and we're not working with the decimals at this point. So now I'm just going to multiply my pieces. 2 times 3 is 6, and put that together. This is our simplified final answer. All right, let's work with the negative. So I'm going to carry that down, and we just did 18, so I know where this is going to go, and I'm already going to use 9 and 2, 9, 2, it's no different than if I had combined over here. I'm just using the negative now, so that would be a negative 12 square root of 2. All right, let's look at it with a variable. All right, so first I'm going to break up my number, 45, and I have 1 and 45, 2 doesn't work, 3 and 15, 4 doesn't work, 5 and 9, 6 doesn't work, 7 doesn't work, 8 doesn't work, and 9 does, but we would go backwards. So we're going to use this on our list. It's our largest perfect square, so I'm going to use this. And then I'm going to break up my variable. Now I want to find something with a square in it, so I would do this times this, because remembering back, when we multiply, we would add our exponents. So I have one here and one here broken apart. So I need to make sure that I get all of this underneath. So I have 5 times 9 times n squared times n. Now I'm going to break it up. Whoops. I don't want the big one, I want little ones. 5, 9, n squared, n. Now, I can't do anything with the 5, so I'm going to bring that down. I can do something with the n, with the 9. That would be a 3, so I'm going to put that on my outside. I can do something with this. That would be an n, so I'm going to put it right here. And I can't do anything with this, so that would be here. Now let's put it all back together. That would be our final answer. Give these a try.